Now let's look at the next law, which we'll call Avogadro. Well, we're not going to call it. It's actually called Avogadro's law. And this is the law that relates volume to gas molecules. And number of gas molecules we are going to indicate by N, which is going to stand for number of moles. Now, we see Avogadro's law in motion anytime we blow up a balloon. Our pressure and our temperature is going to stay constant. The pressure inside the balloon, no matter how many molecules there are, is going to be atmospheric pressure, and the temperature is going to be room temperature. So when we're blowing up a balloon, we're putting more gas molecules, increasing the number of moles, into the balloon, and we see the volume increase. Now, we also have an initial and final state condition, and if we're solving a problem that has that, this is the equation we're going to use. V1 over N1 equals V2 over N2, where V1 is the volume, N1 number of moles at the initial state, and V2 volume at the second state, and N2 number of moles in the second or final state. Now, as always, the units for the volume needs to be the same. And typically that's liters. And then, of course, the units for moles need to be the same. Now, if you're given grams, you would have to convert your grams to moles by dividing by the molar mass. So let's look at this example. A 4.8 liter sample of helium gas contains 0.22 moles of helium. How many additional moles of helium must be added to obtain a volume of 6.4 liters. Assume constant pressure and temperature. Now, the identity of the gas is given. It's given as helium. But actually, it doesn't matter what gas it is. Any of these gas laws, whether it's Charles, Boyle's, or Avogadro's law, are independent of the gas that it is. So when I write out my information, I'm actually not even going to indicate what gas it is. So as always, we want to write down what we're given, and we have to look carefully at our problem, and we may need to read it more than one time to write out our given information. Our initial volume is 4.8 liters. Our initial number of moles is 0.22 moles. Our final volume is 6.4 liters, and our final number of moles is what we're solving for. So what we want to do is we want to use Avogadro's law. Let's write out the law in its equation format, and we're just going to plug in. Our volume 1, we've already written it out, is 4.8 liters. Our number of moles 1 is 0.22 moles. Our second volume is 6.4 liters, and our second moles is X. Now, I don't know why I put that in parentheses. It doesn't need to be in parentheses. I'm going to change my color of pen now. And what we have now is a proportion, a relationship of equality between two ratios. And to solve for an unknown in a proportion, we are going to cross multiply and then divide by the number that is multiplying our unknown. So I have 4, let me write it up here. I have 4. Don't want that little dot there to be confusing. I don't know if this is helping or not. 4.8 liters times X is equal to, this is too messy. Let me cross that out. Okay, 4.8 liters, now I'll put in parentheses, times X is equal to 0.22 moles times 6.4 liters. Okay, so I'm going to multiply these two together. And when I do, I get, my calculator tells me 1.408, and my units are moles times liter. And then over on the other side, I have 4.8 liters times X. Okay, so I want X all by itself, so I'm going to divide both sides by the 4.8. I'm going to change my pen color so you can clearly see what I'm doing. Okay, so let's see. Divide both sides by 4.8 liters. Okay, so my liters cancel out, and my number and my liters cancel out, because anything divided by itself is 1. So what I end up with is X all by itself, and that's going to be equal to 1.408 divided by 4.8. And I get 0.29 moles. My unit are moles. My moles did not cancel out. So up here, 0.29 moles. Now, does that answer make sense? Well, from our initial to our final state, we increased the volume, and so that means we need to increase the number of moles. So yes, our answer makes sense. Now let's look at another problem. If 1 mole of gas occupies 22.4 liters at STP, what volume would 0.750 moles occupy? So what I would do if I were you is I would pause the voice lecture and I would see if you can work this problem out. And when you're done, turn it back on and we'll go over it. Okay, so the first thing we want to do is we want to write down what we're given. Now, we are given STP, standard temperature and pressure, temperature 273 Kelvin, and pressure 1 atm. But what this is telling us is that our temperature and our pressure is constant. It's not changing. And these are one of the conditions to use Avogadro's law, that you have to have the same temperature and pressure. So we're not going to use these values in any of our calculations. Okay, so what are we given? We're given 1 mole occupies a volume of 22.4 liters. And then what would 0.75 moles occupy? Okie dokie. So in this case, what we're doing is we're writing down our initial conditions, and then in our final condition, we're solving for our final volume. So let's go ahead and write Avogadro's law. And since we've already identified what everything is, we just have to plug in. Our initial volume is 22.4 liters. Our initial number of moles is 1. And then on this side, oh, whoops, I made a mistake up here. What am I doing? This is 0.75 moles. What am I doing here? This is N2. Okay, N2 is 0.75 moles. And then V2 up here is going to be our X. Okay, I'm going to go to a new page because I don't want things to get too messy. Okay, so what we're going to do now that we have this proportion to solve for it, we're going to cross multiply. So I'm going to have 22.4 liters times 0.75, I'm going to put this 0 there, mole is equal to 1 mole times X. And up here I put my units of liters, but I'm just going to leave it as X here. Okay, so when I multiply 22.4 liters times 0.750 moles, I get 16.8 moles times liter. And then on the other side we just have our 1 mole times X. And I just wrote it out this way to show you that it doesn't matter when you're multiplying which order anything goes in. So next I'm going to divide both sides by 1 mole, because that is what is multiplying my unknown of X. My units of moles cancel out here. My units of moles as well as my 1 cancel out here because anything divided by itself is 1. And then I have 16.8 liters. Okay, so our X up here is 16.8 liters. Does that make sense? Yes, if we look at our initial condition, I had 1 mole and then I lowered my number of moles. If I lower my number of moles of gas, then I'm going to lower my volume. And that's exactly what I see. And this is a reasonable answer.